Okay, we're just going to dive in. This is the store the player's progress video. So when the game enters sleep mode, when the player exits sleep mode, when the game quits, all that kind of stuff. The key thing to get right in all of this is we're going to look at, actually you should take a look at this page here, which is the execution order. So inside this execution order, it tells us where things happen. So we're really concerned about when we can load the data and when we can save the data. Now, the best place to load and save data is you load it when the level starts and you save it when the level ends. And that's it. There should be no date. There should be no disk access, which means you shouldn't serialize things to disk or from disk in the middle of gameplay. And the reason why is because things become a little bit choppy. Now, it's kind of ironic the fact that I'm actually looking at the task manager just now, and this looks like it's going to be choppy as well. So this is the second time I've recorded this, and for whatever reason this video seems to just spike up my CPU usage. I don't know why. It's not like it's a crazy topic, but whatever. Okay. So I have my notes from the previous time. The only thing that we need to save in our sort of game data, I'm going to try and put these notes here so that you can see them, so I'm not taking my eyes off the screen too much, is that we need to have some place to store that data, and then we need to be able to bring that data back. Now we're going to use the persistent storage location for this, and we're also going to write just a little helper class for that. So we're going to need two new classes. So the first one is going to be the data itself. So I'm going to call this save game. You could call it save game data, save game model, that kind of thing. I'm just going to call it save game, and then I'm going to create another one here called save game controller. Save game controller. And my CPU is spiked up to 95% already. This does not bode well. Okay, and then we're going to go back to here and then click on reload. And I'm going to, sorry, I keep looking over at Task Manager. I'm very concerned that I'm going to like lose frames and sort of, because basically my previous version of this, I've viewed it back and I was typing stuff and nothing would appear on the screen, so I'm a bit concerned that that's going to happen here. So save game. Okay, save game is super simple. We don't actually, it's just a plain old C# class or plain old C# object, POCO, and it's going to take one member field, which is an integer, and it is the current level. That's it. That's all we need in there. And we also need to add serializable. Serializable. And the only thing we need for that is our system. And that's it. That's all our classes. That's all we're going to write out. And we're going to rely on the JSON utility to save and load this from disk. However, we're going to write our own wrapper around it. And it's best to do this. This is where I guess sort of experience comes into play, is when do you split up classes? And really the general rule of thumb is when you have a class that does two things or more. You really need to split that class up and then have the responsibility of those things happen in other classes. Another class can bring all those things together, so you can think of a game controller as controlling everything, that controls the whole game, but the game controller doesn't contain code to save things to disk. That's done by another class. It doesn't contain some of my examples I do have like input in there, but you would have that as like another input type controller in there. So you want to have a single responsibility for your class. It's only responsible for one thing and one thing only. So our new class, our save game controller, does exactly that. It is only responsible for one thing, and that is saving and loading things from disk. So with that in mind, we're going to have two methods here. We're going to have a void awake. So when this wakes up, and we are going to have if I can type, public void save progress int level. Okay, so that is our, sorry, oh, it just doesn't want to play, does it? That is our save game controller class interface. So we're going to do our load from disk here, save to disk from here. Now we also want to signal that we're ready. Now the way that we're going to signal that we're ready is we're going to have a private Boolean value in here called isReady. And actually, sorry, that's going to be public. And that is going to be property set. Now the reason why I want to make it, well, actually it doesn't need to be a property. It's just I don't want people to write to it from the outside. So I could make it a field, and then I could do hide in inspector, because I don't want people to be able to like tap, like designers, I don't want them to tap it inside the inspector. But I think in this case I'm going to make it isReady is going to be a public property, not a field. So to signal that we're ready, isReady is going to be set to be true. Now why do we need to signal that we're ready? Well, if I close everything else, game controller is going to have inside here we have an awake. So we're going to change this to a start, and we're going to wait until the game controller is ready, and then instead of setting this current level, which is now set to this debug value, remember we set this start to debug, we're going to bring that current level in from the game save in here. Okay, so that's the plan. And where are we? We have we need to know the location of the file, and we also need to know we also need to bring in that value if it exists. So we also need to have a public, sorry, this is getting in the way, int current level get private set. So again, you cannot set this from the outside world. This is only able to be set from inside this class. So our current level is set there, and then we have a private string which is the save file location. So save file location, where is the save file? Save file location equals, and it's going to be application dot persistent data path, but we also need to add the file that we want to save it to. So that is going to be path dot combine, and then the path plus whatever the file name is. So in this case, it's going to be savegame.json, and that's that there. And so this has got a red squiggly line against it. So what we need to do is we need to add using system.io, because this is part of the input-output library, or I/O library. So that gives us our save game location. Now we need to make sure if it exists, we want to load that value in and read that value back. So we're going to say if file.exists save file location, and then this is going to be all the JSON inside there. So remember, we're saving everything as JSON. Is going to be JSON utility dot, actually sorry, we need to do file read all text save file location, and then that gets us the JSON from the file. So whatever the contents of that file is, and we'll show you this in just a sec. And now we need to get that JSON formatted string into the object. So our object is going to be our save game equals JSON utility dot from JSON and then we specify the type that we wanted to convert to, and then it's going to be the contents of that file. So that's going to get us those files there, and then we say current level equals save game dot, and now we have our access to our current level. So this is fairly similar to what we've done before in the serial. Like if this is kind of new to you and you're not following us, up there should be a link to the. If there isn't, complain in the comments below. There should be a link up there to the serialization code that we've done before. Okay. And if it doesn't exist, so if the file doesn't exist, then we want to say current level equals 1. So the file doesn't exist. And I think that's everything there. So we've got our load from disk. So we want to, this is the file location. So this is us setting up the class for the first time. So awake, remember, is kind of like the constructor in Unity. We can't use constructors for mono behavior. We have to use awake. That's our version of the constructor. So inside here, we're saying the file location is going to be the persistent data path plus this savegame.json file. And you can call this whatever you want. You can call it save or game.dat. You can call it whatever you want. I'm calling it savegame.json because it's a JSON file and it's the save game data. So then we check to see if the file exists, and if it does, we read in the entire contents. We then convert those contents from JSON, because it should be a JSON formatted string, into our game object here, which is save game, and then we set the current value to be there. And if the file doesn't exist, then we set our current level to be 1, and then we signal that we're ready. So, saving progress, save the game to disk here. This is a little bit easier because all we have to do is convert that value across. So our save progress, we're going to assign the value that we pass in here. So we're going to say current level equals level. So that's just going to be the current level. And then we're going to say var save game equals new save game. And then we specify current level equals current level. So a couple of things going on in here. First of all, I may have not explained about var. var you should only use if this bit over here is fairly obvious what it is. So if you're going to do var name equals Sloan, then you know that name is going to be a string. So you don't need to put string name equals Sloan because it's obvious it's a string. So when you use var, all you're doing is you're saying, okay, I know what the thing on the right hand side of the equal sign is. I don't need to say it again. It prevents you from doing things like list thing list of things equals new list thing, something like that. You can just put in var and it just saves you typing. It's just a little syntactic sugar that allows you to save typing. The next thing, I don't have a constructor for my save game. So save game is just a plain old C# object. It doesn't have anything in it. It just has one field. Doesn't have anything in it. It's just got one field. Okay, but it doesn't have a constructor. So how do I set this? Well, what I can do is I can use my class initializer here, and I can specify the field or property on this side equals and then a value on this side. And I know what the value is because I've just got it in from here. So this is just a neat way of initializing an object when you don't have a constructor for that object. And I've used that a few times, and again, I can't remember if I've explained what that actually does. So now that we have our object, we can get it into JSON. So we can do var JSON equals JSON utility dot to JSON, and then the object save game, and then that gives us our save game, and then we just write the contents out to that file. So we do file dot write all text, and this will write all text will just obliterate whatever text was there before and will write the new text in there, which is super handy. save file location, comma, and then the contents, which is going to be our JSON file. And that's it. That is our save progress. So we can get rid of this comment here, and we can get rid of signal that we're ready, and we can get rid of that there. Okay. And that's our save game controller class. So the save progress, we went over the awake, what that does in there, and then save progress. Save progress just sets the current level, creates an instance of our save game object, and then we use the JSON utility to do that. You could write something that would just write out just plain string. You could use like string builder or whatever, but this makes it a lot easier, and it reduces the amount of code that you have to write, and that's really important because when you look at a class like this, and it's got like 38 lines of code, including all the squiggly braces and all that kind of stuff. When you look at this and you're trying to fix a bug or you're trying to add a feature, you have 38 lines to look at. If you have a class with 2,000 lines in it, you don't know which ones do what and all this kind of stuff. So it makes much more sense to have smaller and smaller classes. And also from a reusability point of view, if you have smaller and smaller classes, then you could use this for anything that you wanted, the save game controller. In fact, in theory, what you could do is, instead of a save game controller here for save game, what you can do is you could abstract this completely and then just let people pass in the save game, the type themselves. So that's a way forward. I'll leave that as an exercise for you. So rather than typing in level, you'd pass in the save game type, and you can make this all generic and all this kind of stuff. So you can actually make this a little bit easy for yourself. Okay, so that's our save game controller. Let's not refactor it just now. All right, so in game controller, I am going to say require component save game controller. Not that it really helps, but just so that we know. And I'm going to add one not in there. I'm going to add save game controller. Save game controller. Actually, let's just call that save. Let's just call it save. It's easier to work with. And then inside our awake, we don't want an awake anymore. What we want is we want an IEnumerator start, which means I will need to add using system.collections. And system.collections is there. So now I have my start here. Now, why did I do that? Well, what I want to do is I want to say save equals get component save game controller. And then I want to say while not save is ready, yield return null. Okay, so if the save game controller hasn't started, I don't want to start the game. So I don't want to update the UI, I don't want to miss the ball, all that kind of stuff. I don't want to do anything until I have got the save game. And then once I've got the save game, I want to say current level equals save dot current level, taps left equals save dot current level. And now I can reset this to 1, and I can get rid of this line here. So debug purposes only should be 1 for shipping game. So it is 1 for shipping game now. So taps left is now going to be set to 1 as well. Okay. So inside unlock finished. So at this point here we have our current level. What I want to do is this is our interstitial screen. So our interstitial screen is a great place to save data, and that's exactly what we're going to do. So we're going to do save dot save progress, and then it's going to be what did I have in here? New level. Level +1, I think. It is, I think. So I want to add the save progress in here to be whatever the current level is +1. Or is it current level +1? Let's leave it as current level just now because we can examine it and it gives an idea to show where the file is as well. So we'll just leave it as current level just now. I think that's right. And then where else are we? We also need to have when the application has lost focus. What do I want to do? Let me think here. So when the application has lost focus, I don't want to rip the player off when they come back. So the problem is that when they come back from the game, they're going to be halfway through. So let me play through the game first of all, so we can show where the folder is, so we can get that out the road, and then we can figure out the on application focus. So everything is compiled. I'm going to run the game, and we unlock it, and then we get a null reference because we haven't set the game controller up properly. So I'm going to add component save game controller to there, and we will go again. Okay. So we unlock, and then we're on level 2. Okay, this is an old version of the code. Oh dear. This is a disaster. Okay. Well, it's not too bad. So what I want to show is that we now have inside our app data local low and then the name of the company. So in my case, it's Sloan Kelly. There is a folder called lock poppers, and inside there is a file called savegame.json. And if I open that with Sublime Edit, you'll see that our current level is 2. So now when we go back and play the game, so I've closed the game, we go back and play the game will now be on level 2. So when we start, we then move, and then it does the 2, and it unlocks the lock. And then we're on level 3. Okay. So yes, this is an older version of the code, but it still functionally works as well. So so now our current, thanks to Sublime Edit, it automatically does it. So now our current level is on level 3. So the only thing is that when we lose focus, when you're playing the game on a mobile device, we want to be able to go back to that game and then just play the level from the start. I think. Do we? Actually, you know what? Let's leave that, because if you're up at level 152, you don't really want to start, and you're down at 12 ticks left. You don't really want to start 152. So I'm going to not do that. Okay. Let's go over what we changed here. All right. So save game, super simple. It just has the current level. You can put other things in here. You can put in the high score, all that kind of information, whatever you want to put in there. You can put inside the save game, and then it will just serialize it and it'll put it inside savegame.json, which of course goes inside your company name and then your application name. And for Windows, that's inside your app data local low folder. If you want to know, if you go to here, file, and then we go to build settings, I think it is, and then player settings, you'll see that we have company name and then product name. So Lock Poppers is the product name, company name is Sloan Kelly, and that's what this folder represents, is Sloan Kelly Lock Poppers, and the persistent folder is this folder here, the Lock Poppers folder, but its base folder is app data local low. So that is our save game. The save game controller or manager or service or whatever you want to call it is, again, very, very simple. When we awake, that's when we load the data from that storage location. If that file exists, then we go through and we grab all the contents of it, and then we set the value. Otherwise, we just set the value. And then to save the progress, we set the current level just to convenience more than anything else. And then we do the opposite. We serialize that. We create an object of save game, and then we serialize it and then write all that data out to the file. Now, the only two times we use this inside the game controller is part of the start up process. So we go grab the save game controller, we wait until it becomes ready, and then we set the value for our current level. Now, if we didn't do this part here, we would probably get a 0 inside here. Just depending on the timing of things. You can't guarantee when each mono behavior loads. There's no, well, I suppose there's some ways you can load one thing before another, but it's a bit hit and miss as far as Unity is concerned. So this is what an easy solution is, to have this is ready in there. That's one way that I've found to sort of solve the problem. But this is our sort of deserialization part, where we go and grab the contents from that file. The second part is down inside here, where we say, okay, when we're showing the interstitial screen, so we do that lock thing, that's when we want to write out the progress to disk, because the player's it's not part of the normal gameplay, so we don't need to worry about if there's maybe a little bit of slowdown or whatever, because it's at the end of the game, and you're not really playing the player's not playing the game at that point. So that's a good place to go. And that's it. That's the save game for Lock Poppers. And yeah, once again, I'd like to thank you for your time. It's very much appreciated. I hope you're enjoying this this series. I don't know what to call it. Just a collection of games, videos about making a game. And I'll catch you next time. If you like this video, thumbs up or thumbs down if you didn't like it. Don't forget to subscribe if you like this content. Tell your friends. Feel free to share on any social media that you have. Mastodon, Twitter, IRC, Carrier Pigeon. I don't know. Facebook even. Facebook would be fine. I also have a Facebook page as well, which just posts up when I post up a video, which is pretty much what my Twitter account does as well. Yeah, so again, thank you again for again, thank you again, thank you again, thank you again, thank you for watching, and I will catch you in the next video. Bye bye.